Hey, this is Mr. Beckstrom, and I wanted to take a look at a sample problem from section 2.2. This is similar to number 14, and it says write a piecewise function for this graph here, this curve here. So, piecewise functions are a little bit different because a piecewise function is it's a set of different functions kind of all combined into one. So notice that it stops right there, and then it kind of changes directions abruptly. It's not a smooth kind of curve. There's a jagged edge there. And we can do those kinds of functions with piecewise functions. So notice the first thing. First thing I want you to see is that at this line here, if you were to draw like a dotted line here, at x is equal to -2, so at x, your x value equal to -2, this is where this graph kind of changes direction. So really we have kind of two functions here. We have the function where it's one thing kind of to the left of -2, and it's one thing to the right of -2. So that's what we want to do. We want to split this thing where it's one function when x is less than -2, and it's one function when x is greater than -2. And it really doesn't matter which one has the equality in it, because we can see this is a closed dot, so we just have to make sure that one of those has the greater than or equal to, or one of them has the less than or equal to. And you can see all of these have one of each. So that's all we need to worry about. Greater than, less than, greater than, less than. So all of these split in the correct place. So if some of them split somewhere else, then we would know we could kind of process of elimination those out. So the next thing I want to do is I want to take a look at the slopes of these and look to see which one the kind of the easier slope is. Now if I look to the right, I notice I'm going up one to the right one, up one to the right one, up one to the right one. And so I should know that that is a 1/1 slope, right? So m is equal to 1/1, which is just 1. And let's also take a look to see where my y-intercept is. I have a y-intercept at 1 right here, because this is where it's going through the y-axis. So that's equal to 1. So if I were to write a function for that, I could say y is equal to 1x plus 1. And that's true. That is true when x is greater than -2. So x is greater than -2, x plus 1. So it could be this one. X is greater than -2. That's definitely not it. So I can cancel that one out. X is greater than or equal to -2. X plus 1 could be that one. And x is greater than or -2. That's definitely not it, because we have a positive slope. So I can cancel that one out. So now I am down to two possible answers. It's either going to be A or it's going to be C. So let's take a look about this other side here. The other one, it looks like it is going up one to the left one, up one to the left one. So that's definitely a -1 slope. So let me write that. And this is -1 slope, and it looks like we can't really see where it's going to hit the y-axis, but it looks like it's going to be 1, 2, 3 if we were to extend this. So I'm going to guess -3, which gives me, when x is less than -2, gives me y is equal to -x minus 3. And that one's definitely it. That one has completely the wrong slope there. So this is the one I am going with, and that is my answer. All right, so not too bad. Another thing you could do is find points on here and just plug them into each one of these to make sure that it gives you the right y value, and do that on both sides until you kind of eliminate all the ones that you don't want. But if you check the slopes and the y-intercepts, by finding the slopes and then using those slopes to get your y-intercepts for the side that doesn't explicitly give it to you, you can do it that way as well. If you have any questions, let me know, and have a great week. Thanks.